Welcome to the webinar. So my name is Greg Siraki. I'm part of the Habana Labs team. And we are here today with Regis from Hugging Face to talk about how to use DeepSpeed to train faster, cheaper, larger transformer-based models on Hugging Face using Habana Gaudi. This session is being recorded, and we will have this for review offline after the content is over. There'll be a small survey at the end of the presentation, so please stick around at the end to provide any feedback you have. And if you have any issues or questions, you can use the chat feature. We also will have the Q&A section open for question and answer. So anyone can post questions during the presentation, and we'll either stop and answer them, or we'll have a dedicated QA section at the end. So let's begin our session. Regis?
Yeah, hi folks. I'm Regis PR, machine learning engineer at Hugging Face in the optimization team. And I'm the core maintainer of Optimum Habana, which we are going to talk about today. So yeah, let's get started. And let's get started with what I call deep learning 1.0. By this, I mean that how deep learning has been done in the last few years. Basically, we were using neural networks, mainly convolutional or recurrent neural networks, which were actually pretty old architectures, but which were doing a very nice job. Actually, they got a lot of success. They emerged about 10 years ago because we got a lot of data. This enabled to get very good models, but also there are issues because you need to clean this data, you need to pre-process it. So it actually takes quite a lot of time to build a data set so that your model can train on it. Also, another factor that contributed to the emergence of neural networks in the last few years is the hardware we had, GPUs. So those are massively parallel chips that were quite well adapted for the kind of computations that were done for training neural networks. And they do a pretty good job, but they have also some drawbacks. You know, they consume quite a lot of power. They are also quite expensive. So this is how it has almost always been done so far. And we will talk a bit more after. And then all the tools that were available for people to train their models, to do inference, required quite a lot of expertise in AI. Like I remember 6 years ago, I was using Caffe to train my neural networks, and Caffe was great, but you needed to have knowledge in AI to use this tool. So that not any developer could have basically trained his own model. So there was like, yes, quite a lot of knowledge were required. And today, which is what I call deep learning 2.0, actually it could be 1.1, we'll know in the future. Today now it's starting, it has changed already. The kind of architecture that we are using now, there are a lot of architectures that are based on the transformers, which now are used. I mean, they have been used heavily in NLP for a few years already. Now they are used in computer vision, in speech also. So this is really a new type of architecture that is now massively used. Also, now with these big architectures that are very powerful and very efficient, now we can do transfer learning. We could already do it before, but now it's really, really useful because we have such big models that can actually be pre-trained by a few people in the field of AI. And this pre-trained model can be used then to just fine-tune these models on your small data set, and you will get very good results. So you don't need to gather so many data to build such a big data set and do all this cleaning and all this pre-processing to build a huge data set and so that you can train your model. You can just do transfer learning so that you fine-tune an already pre-trained model on your data, even if your data set is rather small, and you will get very good results. Also now, there is dedicated hardware for machine learning and for deep learning. which actually are trying to solve the issues that I mentioned before of GPUs. And that's actually why we are here today to talk with Habana about what we can do in this field. And also the tools now are less, they require less expertise, less AI expertise. Now you don't need to be a data scientist or an expert in AI to train your model, to do inference, or to build an application based on deep learning model. Now these tools are much more user-friendly, and any developer can use them, and we are going to show why. So talking about transformers, transformers is actually the name of the most popular library at Hugging Face. It's got really a huge success among open source libraries. So here is a graph like with the most popular open source projects over the last few years. And we can see that transformers in yellow has the steepest curve and really has got a lot of success recently. And that's really big. That's really good for us because the community is growing and it's already quite big. And we are doing quite a lot of things with our community. We are doing things for them and with them, which is important. But it's not only about like people who are trying just for fun or for small applications, the models we have in the Transformers library. It's also in the industry. There are more and more people in the industry using this kind of models. So transformers are really now becoming the norm in the industry for many applications. And this has been recognized in several reports on AI in the industry. So basically, recurrent neural networks and convolutional neural networks, the usage is going down, which doesn't mean that, for example, you will not find this kind of architectures in transformers. You will be able to find some, but now state-of-the-art architectures are based on transformers, and that's most architectures will be based on this. And just to give you a few figures about our hub, which we call like this at Hugging Face. This is a place where basically everyone can upload models, data sets, demos, and everyone can use them also. So right now, basically, we have more than 100,000 hub users, which is great because that means there are many people uploading new models, using new models, uploading new data sets. So that's really a huge resource for people wanting to try AI or wanting to even go farther and really get the best performance they can get. And also the Transformers library is now downloaded more than 1 million times daily, which shows that there is really a big community around the Transformers library and what we do at Hugging Face. So here, Greg, I'm going to let you speak a little bit about what you do at Habana and what your goal is.
Yeah, so we look at this explosive demand for deep learning. So we see this need across all business now, aggressively incorporating artificial intelligence, machine learning, and deep learning into applications that span across all forms of business. And so we see this increasing demand for applications, and then people that are already putting AI into their workflows are now including larger models, more complex models, more data sets, as we see, people aggressively using data on the edge and IoT. We're generating a huge amount of data. And this really drives the ability to have bigger models, bigger data sets, more accurate models that really can drive business and make a significant impact in people's businesses. So you can see here from some of this IDC informational survey, we see that of that survey, 74% indicated that they are running some iterations of training. And half of those are building their models weekly or more often. I think the most interesting piece of this is, over 1 in 4 people surveyed are rebuilding their models and training daily or hourly. And so this really drives the need to have a low cost, highly efficient, easy to use environment to be able to do this on a daily basis. And so when these models get bigger and bigger, cost becomes a significant impact to how businesses will implement AI and machine learning in their normal workflows. So this really drives a question of how do we make sure that the industry has a cost-effective, easy-to-use solution that is really custom designed for deep learning. So we look ahead to Gaudi. And so that's what we're talking about today is the Gaudi AI training processor. And the most important thing to remember here is that Gaudi is a bespoke design processor designed from the ground up for deep learning and machine learning. This is different than a traditional CPU or a GPU that was migrated over to run the types of deep learning workloads. Gaudi was designed from the ground up to be a deep learning accelerator. And so we have a dedicated matrix multiplication engine and programmable tensor processing cores to handle all kinds of workloads and operations. We have a dedicated 32 gigabytes of on-die HBM or high bandwidth memory to hold larger models more efficiently, and also a fully dedicated 10 100 gigabyte Ethernet ports on chip. And this is really unique in that other solutions are depending upon host-based NIC solutions, host-based communication solutions for cross-node communication. In this case, all of our Gaudi devices have these onboard Ethernet ports for both communication on node between chips inside a node and across node. So for scale out across multiple nodes to scale across very, very large configurations. This is really the important piece to drive efficiency. Now, from a software point of view, we've also defined the Synapse AI software stack. And our software suite here is designed for performance and ease of use. So we fully integrate PyTorch and TensorFlow to really make it easy for people to take existing PyTorch and TensorFlow models and integrate them into the Synapse software stack. This makes it very easy to migrate existing models over to the Synapse and Gaudi architecture. And for those of you that would like more information on how to do that basic model migration, we're sponsoring a workshop on Tuesday, October 25th, where we'll walk through those simple steps to help migrate models over to Gaudi. So if you're interested, you can go to the developer Habana developer page and our events and sign up for that workshop where you'll have some hands-on activities to do that model migration. Our library has a built-in graph compiler and optimized kernels. So all of these things happen under the hood that are really transparent to the users, but are driving very high efficiency, very high performance integration with PyTorch and TensorFlow. And then, of course, you look at our rich suite of documentation and tools from our developer site and GitHub. We have a suite of over 35 models now that we sponsor on our GitHub site and our developer forum for additional information and engagement with the community.
Thanks, Greg. That's really interesting, and that's really complementary to what we are trying to do at Hugging Face. So here is an overview of the Hugging Face ecosystem. Basically, where you can see on the right, there are a lot of data sets and models on the hub. So you will really be able to find data sets in any modality you want, many of them, many different models, also state-of-the-art models, also models that some people train on their own data sets. So you really be able to find many of them. And then we have, of course, the transformers library, which make it easy to train these models, to do like basically any kind of deep learning workflow you want. And with this, we have the Optimum library, which is built on top of transformers and which will basically enable users to accelerate their training or inference workflows. And that's where it's very interesting to what Greg presented, to work with Habana, because there is really something to do here for accelerating training. And next to this, we have also Spaces, which basically enables to build web applications very easily. It's not so easy actually when you have like a very good model to showcase it to the whole world. And with Spaces, you can build a simple Gradio or Streamlit demo, which will basically show what your model can do in a very, very easy way. And you can also use our new inference endpoints to deploy your model in production, which will enable you to deploy your model basically on an endpoint where you will get the best performance according to what you want, according to your constraints. And we also have some partnerships with some cloud providers like Amazon and Microsoft to deploy models, for example, with Amazon SageMaker and with Microsoft Azure. So I'm going to now talk a bit more about Optimum, since, as I told you, so I'm in the optimization team, and basically my team works on the development of Optimum, which is an open source library. So you can find it here at this URL. So it's open source, it's on GitHub. You can check the source code. There is a documentation, there are examples on how to use it. And the goal is really to accelerate training and inference on the hardware you're targeting. So for inference, for example, we provide an easy API to do quantization to accelerate your models. And for training, we work with partners like Habana to enable the functionalities of the transformers library, but optimize for this specific hardware. And basically what is cool, and that I'm going to show you in the next slide, is that there are minimal changes to your existing code. Let's say you have a code working with transformers. If you want to deploy this code on Habana Gaudi, basically you will just need to use Optimum Habana, but you will see the changes are very minimal. And as I said, so we have support for Habana Gaudi, so you can deploy your deep learning workflows either on a single device, on a single HPU. See, one Gaudi is actually has 8 HPUs, so you can deploy your model on 1 or even 8 HPUs to do distributed training. And now we also support DeepSpeed, so you can train larger models on your 8 HPUs. So basically you can now train models with billions of parameters on Gaudi, and that's will be actually the subject of the demonstration I'm going to do in a few minutes. But I really want to show you, so what I was talking about, how easy it is to pass from transformers to Optimum Habana. So in the upper part of this slide, you can see you have like a basic script that works on transformers. So basically here, so you have a trainer, you have training arguments that you define, and then you link the training arguments with the trainer, and you just call the train method, and that will launch your training. If you have this script and you want to pass to Optimum Habana because you want to deploy it on Gaudi, basically you will just need to change the two classes for their Habana counterpart, so the trainer for Gaudi trainer and the training arguments for Gaudi training arguments. And basically there will just be a few additional training arguments that you need to set. So there are 3 of them that I'm going to detail a bit more in the demonstration. But then the API is exactly the same. You call the training exactly the same way. So it's really easy to convert your transformer script to a Habana script. And basically, so I'm going to show it to you now in a demonstration using DeepSpeed, since I told you it is a recent feature that we added to Optimum Habana. So I'm not going to detail how to set up your DL1 instance on AWS. You can check either the documentation of the repository, or you can check also this blog article that explains in detail how to do it. And I'm going to actually present you a notebook that you can find here on GitHub in the repository of Optimum Habana. So here is a notebook that actually you will be able to find in the repository. So basically, you can see it's an empty notebook. There is no output yet. I'm going to launch everything now so that basically all the computation is done while I'm talking, and then we will see the output we get. And here I would like to show you an example of fine-tuning GPT-2XL with Optimum Habana. GPT-2XL is a decoder model that has 1.6 billion parameters, and you cannot train it on Gaudi without DeepSpeed. So I really want you to show I really want to show you the advanced features that are now available in Optimum Habana. And I put here a few links. So there is a link to the documentation that I encourage you to go if you really want to see examples of how to use the advanced features of Optimum Habana. Also a link to the GitHub package repository. And here in this demonstration, we are using GPT-2XL, but you could use any other model that has been validated for the package. So in the documentation, you will find this table that sums it up. These are all the models that we validated. So you're sure that this model will work for the use case that is described in each column. So right now we have a few NLP models and also 2 computer vision models. And basically, this is not over, because over time we add new models, new modalities also. We are not going to stop to text and vision. And one thing that I want to emphasize here is that these models have been officially validated, but that doesn't mean that other models of the Transformers library don't work with Optimum Habana. For example, like the last few models that were added, like GPT-2 or Swin, they worked out of the box. The first time I tried them, they worked out of the box with Optimum Habana. So I really encourage you to even use other model of the Transformers library. And if you encounter any issue, don't hesitate to open an issue or open a PR in the GitHub repository of Optimum Habana. So here with GPT-2XL, we are going to run an example of causal language modeling. So just to give you an example, in causal language modeling, what we want to do is to predict what will happen next in a sentence. So here is an example. So we have a prompt which says, this live AI webinar is organized by Habana Labs and Hugging Face, and the sentence is obviously not finished. So we would like the model to generate the end of the sentence in, of course, a realistic way. So basically, what the model is going to do is that it's just going for training to look at the context at the left of where it has to generate the new tokens, the new words. And training on this objective, it will be able then to generate new sentences, which I will show you at the end with our model that has been fine-tuned. So the training script that we are using here is the run-clm.py example script that you can find in the GitHub repository. So basically, you will see here there is an examples repository, and there are a lot of different tasks. So there is a script for each one of these tasks. And for language modeling, we use the run-clm.py script. And you have also a README that's explain you how to use this script, etc. But I'm going to show you in more detail now how to do it. And basically in this script, it does a lot of things. It will download and pre-process the dataset. It's going to instantiate the model. So either by downloading a pre-trained checkpoint, if you want to do fine-tuning, as we are going to do now, or initializing a new checkpoint if you want to train your model from scratch. It will download the tokenizer, and then it will do the training and the evaluation. And basically, this example I'm going to show you enables you to either fine-tune or pre-train your model. And as I said in the small example that I showed in the previous slide, basically, the only difference between the run-clm.py from Optimum Habana and the one from Transformers is just the trainer class and the training argument class that we use. So it's really this, and that's why it's really easy to pass from Transformers to Optimum Habana. So the dataset that we are going to use is a Wikitext language modeling dataset. So basically, you can find more information about this dataset on the Hugging Face Hub. I put a link here if you really want to look a bit more how it looks like and get more information about it. And the first thing that you will need to do is to actually install the package. So basically, you can just pip install the package. It's available on PyPy. And here I installed the version 1.2.2, which is the latest one. So this is the latest release. Yeah, just it's very easy to install. You can also install it from source, starting from the GitHub repository if you would like to have the really latest advancements. But there are regular releases on PyPy, so you can. I encourage you to do it because it's very easy to do. And here, so yes, this is installed. Here are a few dependencies that were also that we need to install for this example. Actually, in the example repository that I showed you, there is for each example there is a requirements file where all the requirements are listed, and you can install them. So here we do it here. And then, as I told you, what we want to do is to fine-tune GPT-2XL on 8 HPOs, because basically this notebook is run on AWS DL1 instance. And basically this corresponds to one Gaudi. And on one Gaudi, we have 8 HPOs, and we are going to use all of them. So first, we need to specify the training arguments we want to use for our run. So here are the training arguments that you would specify in transformers. So all these training arguments are common with transformers. So I'm not going to detail them much, but this is where basically you can set your hyperparameters, like the number of epochs, your batch size, the learning rate if you want, etc., etc. So all these arguments are the same as in transformers. Now here is the code snippets that is important if you want to do pre-training. So here, if you want to change it, just change this variable pre-training to true. And in that case, what actually happens in the script is that it's not going to download a pre-trained model. It's going to instantiate a model from scratch from the model configuration. So as I said, you can just set it to true, and in that case, you will do pre-training. And here are the Gaudi related arguments. So these 4 arguments are specific to Optimum Habana. So the first one, use Habana, means that you want to run your script on Gaudi, on HPUs. The second one, use lazy mode, means that basically you want to use lazy mode. So basically on Gaudi, you can either use eager mode or lazy mode. So in eager mode, operations are computed one operation at a time, whereas in lazy mode, basically what is being done is that we accumulate the operations in a graph, and at some point, we trigger a compilation of the graph to do some optimizations so that it runs faster. And that's here what we are going to do. Also, you need to specify a Gaudi configuration. So here with the argument Gaudi config name. So this is basically what I encourage you to do is to just specify an already existing configuration. So here we are going to use the Habana GPT-2 configuration, and you can find actually on this link all the existing Gaudi configuration. So actually this is the page of the Habana organization on the Hugging Face Hub. And we see here that we have several models. And actually for each one of these models, there is a Gaudi configuration that you can use. So let's see, for example, at Albert Large V2. So there is a small model card here that explains a bit so the different things you have in your Gaudi configuration and how to use it on an example of Optimum Habana. And I'm going to just show you very quickly. So this is how a Gaudi configuration file looks like. Basically, that's where we can specify if we want to do mixed precision training or not. And if yes, specify which operations should be computed in BF16, which operations should be computed in FP32, etc. And also, we can choose to use some optimized operators, so operators that were optimized by Habana for Gaudi, like a fused Adam or the fused clip norm. So here, since we use GPT-2, we are going to use the existing Habana GPT-2 Gaudi configuration. And the last argument, throughput warm-up steps, is basically just an argument that enables to say, okay, to compute the throughput, don't take into account the first two steps, because in lazy mode, that's in these first two steps that the compilation will take place. So obviously it will take more time, and we just want to compute the throughput after compilation has been done. You can set it to 0. I mean, 0 is the default value if you also want to take into account the compilation time. So to run the script, so I'm going to show you how to do it. There are basically two different ways. Either you can leverage the distributed runner that I'm going to show you in a few seconds. Either you can use a Gaudi spawn.py script that is in the examples repository of Optimum Habana, which enables to do it quite easily. Basically, with a distributed runner, you can customize your script and just use it this way. So basically, you just import the distributed runner, and you're going to give to the distributed runner the command to execute. Here, you're going to specify the world size, so which is basically the number of devices you want to run your training on. So as I told you, on one Gaudi, we have 8 HPUs, so we are going all of these 8 HPUs. And here you can also specify how the communication should be done between the devices. And here we are going to use OpenMPI. Here, this example, so it's I commented it because this example will fail. So if you run it, be careful. It's normal if it fails, because basically GPT-2XL is too big and you will get an out of memory error. And we'll see at the end. Maybe if I have time, I will show you how it looks like. But basically, yes, this is the normal way of doing distributed training. But here, the model is too big. And what we can do is now we can use DeepSpeed, because the Habana team has worked on adapting DeepSpeed for HPUs, and now it has been integrated to Optimum Habana in Optimum Habana 1.2. Now you can use DeepSpeed, which is great because we can train much bigger models like GPT-2XL. And for this, basically what you will need to do is to install basically the fork of DeepSpeed made by Habana to be able to have this DeepSpeed adapted for HPUs. And you will need to specify one more training argument, which is the DeepSpeed configuration you want to use. So in the documentation, we describe a bit how to write your DeepSpeed configuration, and we give some examples. And here we are going to use this one, which is provided. So the notebook is in the notebook repository of the repository of Optimum Habana, and in the config repo you have basically this DeepSpeed configuration. So there are several parameters that were set here, but basically, so here they are like for the batch size, for doing gradient accumulation. Here's the auto value just means that it's going to read it from the training arguments that were provided before, that I described before. We want to do BF16 because, as I told you, Gaudi supports mixed precision training in BF16. And the most important thing here is the zero optimization. There are several stages that DeepSpeed proposes for zero optimization. And here we are going to use stage 2, which means that two kinds of optimizations are going to be performed. The first one is that the optimizer states are going to be split across the processes that are used. So one process per device, and we have 8 devices. And also the second optimization is that the gradients that are computed are also going to be split across these 8 processes. And this enables to save memory, and that's the reason why we are going to be able to train a much bigger model while we couldn't without DeepSpeed. So this is the DeepSpeed configuration we are going to use, and you just need to provide the path to this configuration, and the trainer, the Gaudi trainer, will know that you want to use DeepSpeed with this configuration. So here, basically, we do the same thing as I just described above for distributed training. We have our distributed runner. We have the command we want to run, the number of devices we want to use. And here we have this argument use DeepSpeed. So we want to use DeepSpeed, so we set it to true. And then you just need to call the run method, and it's going to run the training. So there are a lot of logs here, but basically what's interesting is that DeepSpeed is going to log. So first, the trainer is going to log training arguments, everything that is being done, like downloading the data set, the pre-processing that is being done in the training scripts, etc., etc. And then DeepSpeed is also going to display the DeepSpeed configuration that is being used, so that you can check that actually you have like the same configuration as the one you specified. So yeah, it must be. Yes, it's a bit up. Yes, there is a lot of logs. So I don't find it now, but yeah, trust me, it's there. And then it will launch training. So basically doing the type of optimization, the 0-2 optimization that yeah, here it is DeepSpeed. Yeah, the DeepSpeed log. So here are a few logs, and then basically it's going to yeah, here you have your DeepSpeed configuration with all the parameters, even the ones that we didn't specify with their default value. And after that, it will launch the training. So doing the optimization, the 0-2 optimization. And you will see, so here we start running the training. So we display some information, and here we can see that our model does have 1.6 billion parameters. And here, so just for one epoch with a batch size of 4, and we can see here that the training runs well without any out of memory error, thanks to DeepSpeed. So we will see, so here the training should be done. So we are going at the end. So we had 73 training steps. So at the end of the training, there is usually a small recap that is displayed with how long it took, like the throughput you got, the loss you got at the end, etc. And then we are going to start evaluating the model on the evaluation set. So here the evaluation got done while I was talking, and we get some interesting metrics. So we get the evaluation loss, the evaluation accuracy, and the perplexity. That is a metric that is usually used for generating new tokens. So here you have all the metrics to monitor the performance of your model. And we see that the whole script got run successfully, and we managed to get basically a model that we fine-tuned on this Wikitext dataset. As I told you, this would be the exact same thing with pre-training. You just need to change the pre-training parameter. And now that we have a fine-tuned model, basically we are going to use it to generate something. So as I showed you the example at the beginning, we had this example, which is the prompt we are going to use. So this live AI webinar is organized by Habana Labs and Hugging Face, and we are going to see what the model generated. So let's see. So here are 3 propositions. So the first one, for example, this live AI webinar is organized by Habana Labs and Hugging Face and follows the discussion in the previous live AI webinar, which is kind of true because there was a previous webinar and it's actually the following. So yeah, here's the second proposition, the third one. So we see that actually the sentence makes sense. Then of course, we could have fine-tuned the model for many more epochs on another data set. So basically this is up to you and basically what you want to do. And here I display so a small comparison, a small cost comparison between one DL1 AWS DL1 instance, so one Gaudi, and an instance, so the P3.8 X large instance on AWS, which has 4 V100 GPUs, which they have pretty much the same cost per hour. However, here we see that with Gaudi, just for running this fine-tuning on 3 epochs, this will cost us much less than with the V100 GPUs. So this is really interesting, and this is really like a big reason also why we want to enable transformers on Gaudi, because this will enable our users to save a lot of money. And as I told you, so we successfully trained GPT-2 XL, so 1.6 billion parameters, but that doesn't mean that this is the maximum limit. You can train even bigger models, so several billion parameters. So I encourage you to try it and to let us know how it went. And don't forget that you can find more information in the documentation. So here you have the DeepSpeed page of the documentation with a lot of pieces of advice and examples. So I encourage you to read it if you want to run your own script and deploy your own model. So here it is for the demonstration. So I'm going to come back to no. Yes, to the wait. This is from the beginning. So let's come back to the demonstration slide. So yeah, so this is it for the demonstration. And as I told you, I encourage you to run the notebook and to run your own script and let us know how it went. So Greg, I let you talk a bit more about the cost savings on Gaudi.
Yeah, we see that, as we talked about earlier, we see the need to do this type of work on a very regular basis. We see that we showed you that Gaudi is designed to do this work from the ground up. And now, what does this really mean for the bottom line, for performance and cost? So you'll see these three charts here showing Gaudi, which is the blue bar on the left, is performing, when you look at cost per image for ResNet 50, or for a transformer-based model like BERT Large, cost per sequence, that compared to A100 and V100, we're seeing a significant cost improvement or cost reduction to run these models. And you see all the data down below. But really the key point is, as we just showed us earlier, running these models on DL1, on Gaudi, gives our users significant lower cost. But wait, there's more. So we see obviously Gaudi 1 in production on AWS, and you can access that today. But we also now just announced Gaudi 2 earlier this year. So this is really now just leadership performance. So not only are we cost competitive with Gaudi 1, but now really driving the industry compared to other competition. So we see here almost a 2x better throughput versus A100 for ResNet 50 and BERT. And we show that in our MLPerf numbers and this content here today. So we're really driving forward to really drive the industry to support these larger models. And one of the great things about Gaudi 2 is also now we have 96 gigabytes of on-die or on-package HBM memory to really, really accelerate models as they get larger and larger and larger. So we take this improvement, we take the improvements that we just saw here with DeepSpeed, and this really pushes the envelope forward and the ability to really scale up to whatever the industry is going to bring, we'll be able to support it.
Yeah, and that's really exciting. Actually, I can't wait to try Optimum Habana on Gaudi 2, because with this kind of speed up, it will be great. Also with more memory, it will open new possibilities. So that's really great. And yeah, that concludes this presentation. So to wrap up, so we presented how transformers are becoming now the norm in deep learning for everybody also in the industry, and how Habana Gaudi has the best cost performance ratio for transformer training. So this is really important, because if you have huge workloads with transformer training, Habana Gaudi is really going to help you to save some money. And then with Optimum Habana, we saw how to easily train a model with billions of parameters. So I told you, you can train like models with several billions of parameters, not only 1.6. And we saw how easy it is to do this, So that's really something we emphasize, how user-friendly the library should be. And we really care about the feedback that our users give to us. And this is something that is always going to be our main focus. And to give you a few directions for the future, things that we are going to do in the library, we are going to enable multi-node training with DeepSpeed. So what we show today in the demonstration, in the notebook, So was training on one node, one Gaudi. Then basically in the future, so when I say in the future, it will be in the next release in a few weeks, you will be able to use several Gaudis to run your trainings. So that will be great. And also the Habana team has worked hard to enable new inference capabilities on Gaudi. And this is something we want also to integrate to Optimum Habana, because there are a lot of very interesting use cases. I'm thinking to diffusion models, for example. This could be really fun to do it on Gaudi. So this is definitely something we are going to integrate. So to get started and to learn more about Hugging Face and transformers, I encourage you to check out these links. So with all the tasks that you can perform in transformers, the course also, which is very, very cool, very simple, and will show you how to use transformers, and as a consequence, how to use Optimum Habana, because as I told you, the API is exactly the same. I encourage you also to check the Hugging Face page on GitHub to see all the libraries and all the work that is being done at Hugging Face. Yeah, Greg, maybe you want to tell a few words about Habana and the resources you provide.
Right. So the best place to start is our developer webpage. So you can start there, and that gets you connected to our tutorials, our GitHub page, and our collateral. So this is really the best place to start if you're starting on your journey with using Habana. Our tutorials are really a great place to get started, as well as our GitHub models. And then, of course, all of the Hugging Face-based items in that last bullet below.
And don't hesitate if you have any questions that you cannot ask, like right now during this webinar. You can send us emails if you have any question you may have. Don't hesitate to reach out to us, and we will be more than happy to answer you. So I think, yeah, that's it. That sums it up very well. And maybe we have a few questions.
Yeah, so let's grab a few of the questions. So first, I answered a few of them throughout the presentation, but there's one here from an anonymous attendee asking if we have plans to support 0.3 optimizations or fully sharded data parallelism. And so I'll answer that from the Habana perspective. The answer is yes, we're looking to support those in a future release.
Yeah, and that's great. That's also something I'm really looking forward to it, because it will enable to train even bigger models. So yes, definitely that will be great when this is released.
Yep. And then next question from Sandra, is DeepSpeed inference available in Gaudi? Otherwise, when it will be released? So DeepSpeed inference is something that we have under investigation, and this will come out in a future release.
Cool.
Okay, Bjorn's asking, share links, what will work on Gaudi 1? So we'll put the link in here. Maybe Regis, you could go back to the Hugging Face main page, the Habana page, and you can show the
yeah,
the list of models that are
the
validated.
models, yeah. I think it's yeah, it was. So here, yeah, so here is the list. So you have a Gaudi configuration for all the models that are in the table, in this table. So for all these models, I encourage you to use the existing configurations. Then you also have the possibility to write your own configuration if you want to dive more into the advanced features that are proposed. And also, as I told you, you can use existing configurations. Like, for example, if you want to use a decoder model, you can use the GPT-2 Gaudi configuration for another decoder model, and it should work, you know. There might be sometimes a few issues with mixed precision training, because for some models, there are few specificities, so you may have to tweak things a little bit, but usually it will work out of the box for models that were not officially validated. So just, yeah, here's the page.
Okay, we'll stick around for maybe another minute or so. If anyone has any last minute questions they want to put in the Q&A.
Sure. So maybe what I can do also is that since we have like a few minutes, is to actually uncomment this code that I told you would fail at the beginning. So without using DeepSpeed actually. So yeah, so the shortcuts. Okay, so let's do this. So I'm going basically to rerun everything, which should be fast, but yeah, you will see. So here everything is installed, and you will see there will be an out of memory error. And you can see that the logs are actually a bit different because here DeepSpeed is not used, so there won't be the DeepSpeed configuration and this kind of thing. So this is the usual log for distributed training without DeepSpeed. So here's the beginning of the training. So you will see quickly that an error will be raised. And also something that, I mean, we mentioned briefly, but that is very cool is that, as I told you, currently we have two modalities among the models that have been officially validated, text and vision. But we are working on adding more, and especially the next one should be speech. So stay tuned, but by the end of the year, you will have a speech model officially validated, which is very cool because this is something we are trying to push at Hugging Face. There are many different modalities that are possible and many models for each modality. So that's very nice. And just to let you see the error now, so you see that there is actually a memory error. So we needed DeepSpeed to run this training.
That's great. There was a question from Isaac about could we take this example and go from 8 down to 1 card? Can you run this on a single card? The DeepSpeed version.
So the DeepSpeed version, I mean, it's probably not going to work because, as I told you, the kind of optimization it does is that it splits the optimizer states and the gradients across all the processes you have. So on one Gaudi, it will be 8. I mean, if you use the 8 HPUs, which is the reason why you can save some memory because you split the thing. But if you only use one device, you're not going to be able to basically have to save this memory because you cannot split the optimizer states and the gradients across several processes. So on one device, it's not going to work. You will need to use several.
I think that's just the general implication of using DeepSpeed is that you are doing this across multiple devices for those reasons you listed. So
yeah.
I guess it could work. I mean, you look at some of the basic examples from the DeepSpeed tutorials, and they have some very simple ones, but that's really not by design.
Yeah, there are other optimizations that are done by DeepSpeed. So yes, I guess it could work if your model is not that big, but yeah, don't expect it to work with like very big models.
Okay. There's a question about tensor cores similar to A100 tensor cores. I would say that from a Habana perspective, our TPC cores are programmable. They do very similar things to what you'd see in a GPU. But I think the benefit here from our perspective is that we custom our kernel. We create custom kernels in many cases from our graph compiler. to drive performance and sparse workloads. So it's a different architecture. It's a custom architecture. So it does the same thing as a tensor core would do, but it is a custom design. Okay, Bjorn had a few other questions here. Link to best config of Habana server to run with Conda or in a container with Jupyter.
Sorry, Greg.
This is a question for us.
Okay, okay.
Yeah, Ken, thanks for typing that one offline. I think that's more of an offline question beyond the scope of today. Bjorn's asking, is DeepSpeed the same as Megatron LM? No, in this case, Megatron LM is just a model. We look at DeepSpeed as really an optimizer that sits on top of a PyTorch model like Megatron or GPT-2 or GPT-3 that is used to do some of the things that we just talked about a moment ago, to really
exactly
memorize, optimize parameters, gradients, optimizer states to make sure that these larger models can run on a reasonable set of hardware. Okay, we've got about a minute left, so I think we're going to wrap it up. As the call ends, I'd appreciate for those still on the call to fill out the survey. Just a very quick, take you about a minute. We'd love to hear your feedback. And thanks again for participating. And Regis, thank you very much for your great demo here. It was really great.
Thanks, Greg, and thank you all for watching us.
Okay, everybody, have a great day.
Have a great day. Bye.
Bye all.